Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today. A device containing two key elements fails when, and only when, both components fail. The lifetimes T1 and T2 of these components are independent with common density function f of t equal to e to the minus t for t greater than 0. And of course that's the exponential distribution with mean 1. The cost x of operating the device until failure is 2t1 plus t2. Which of the following is the density function of x for x greater than 0? So we are told that t1 and t2 are independent, and then 2t1 and u equal to 2t1 and w equal to t2 are also independent, and t1 can be written as 1/2 of u if u is equal to t1, so that f sub u of u is equal to f sub t1 of t1 corresponding to u times the derivative of the inverse of this transformation, so t1 in terms of expressed in terms of u, which is 1/2 u. So this is f sub t1 of 1/2 u times 1/2, but t1 is exponential with mean 1, so that f of t is e to the minus t, and f sub t1 of 1/2 u is e to the minus 1/2 u. So this is 1/2 e to the minus 1/2 u, which, by the way, of course, is exponential with mean 2. And that's not hard to see, that if t1 is exponential with mean 1, then 2t1 is exponential with mean 2. And u and w are independent. Both are non-negative with probability 1. To find the density of their sum, we can just calculate the convolution of u and v. So take the integral from 0 to x of f sub u of u times f sub w of x minus u du. So f sub x of x for x equal to u plus w is the integral over all possible values of the variable in the first density and variable of the second density, so that they add up to x. And of course that u, that is in f sub u of u, can run from 0 to x. That's why we take the integral from 0 to x, so that as u runs from 0 to x, u plus x minus u add up to x exactly. So that's the point of this convolution calculation. That's the integral from 0 to x of 1/2 e to the minus 1/2 u times w is exponential with mean 1, so f sub w of x minus u is e to the minus x minus u du. Well, then we can factor out 1/2 e to the minus x, which is not a function of u, times take the integral from 0 to x of e to the 1/2 u du. And actually, if you did financial mathematics, you should know that this second thing is just s bar angle x for the interest rate of delta equal to, so not interest rate, but force of interest, delta equal to 1/2. But you don't have to, you can just calculate the integral of this is 2 e to the 1/2 u, evaluated from 0 to x. And this becomes e to the minus 1/2 x minus e to the minus x, which is answer A. Please remember this is copyrighted material. The problem itself comes from the Society of Actuaries, is reproduced with permission. This was previously posted as my online exercise in 2006, and now it is made into a video. And all of these exercises are copyrighted by me, all rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited. Good luck in your studies and good luck on your test.